Hello everyone, very good evening and welcome to interview preparation session. And let's start, begin for the day. Okay, so let's start with decision trees, right? So as a part of tree-based algorithms, right, as a part of classification models, we have things to be understood with respect to classification as well, right? So whenever you have Y being categorical, definitely we opt classification algorithms here. And this comes under, we all know that it is under supervised machine learning algorithm. And this is one of the simplest algorithm. You are not restricting yourself to classification, but also you can use for regression problems also, right? So it is very important that one should have a good sound knowledge on decision trees, right? And to get a clear understanding of the techniques, which covers almost the very minute fundamental concepts to complex things, let's discuss few of them today. So what is the decision tree algorithm all about? How does it work? Yeah. Okay, what is the decision tree algorithm? So it is dividing your complex, maybe it is a combinational data, right? So it divides your entire data set into smaller subsets, right? And it starts incrementing, the tree gets developed, right? And the final output of the tree will be having decision nodes, or we can also call them as leaf nodes or terminal nodes. And the good thing is that the data which is with what we feel as a combinational or a mixed data, where it holds good for categorical and also numerical data, right? You may have your target algorithm for classification like no or yes scenario, right? You may have categorical columns also, or you can also have numeric columns also, right? But the thing what you do is, if at all discretization is required, we have to go for discretization also. Okay. Now, what are the popular algorithms now we use for this algorithm? Like for deriving this decision tree, we have many algorithms, right? Popular algorithms here for deriving a decision tree or to build a decision tree. To build a decision tree. Provided even you have to use their selection measures also, the attribute selection measure also. What are the popular algorithms we can use to build a decision tree? Yeah, first is your ID3, right? First is your ID3, that is iterative dichotomizer. Right? It uses information gain as attribute selection measure. What is the second one? You will use for, maybe you can use card, which is for both classification and regression. Classification and regression. It uses Gini index, right? It uses Gini index, right? You have C4.5, which is a successor of ID3, right? It uses gain ratio. It uses gain ratio as attribute selection measure. Okay. Yeah. Now, let us understand these things in detail. So the most widely used algorithm for decision tree is ID3, and this ID3 uses entropy and information gain as attribute selection measures. Why? To construct a decision tree. So first, if I would like to know from you people, explain entropy. And the second one is information gain. What is this entropy all about? Entropy captures impurity or purity. What is entropy all about? It is a measure of impurity. Is your entropy, right? Measure of impurity is your entropy. So it is, decision tree is built top down from a root node and involves the partition of the data into homogeneous subsets, right? To get the homogeneity of that particular sample, it uses something, what you call it as entropy. Therefore, entropy is 0 when your sample is completely homogeneous, right? And your entropy of 1 when a sample is equally divided between different classes. So how do you calculate that? Sigma I is 1 equal to n. Okay, P of I, P of xi or x of I. Right? Okay, I missed out log, sorry. So entropy is nothing but x of I. This is how you calculate your entropy. Yeah, exactly. So that is your information gain, Ikshita. Correct, exactly what you have written, entropy after, entropy before. It is nothing but you are calculating information gain from before and after. Okay, you calculate entropy gain before and after. So entropy, what is the information gain? Yes, this is based on decrease in the entropy after your split is occurring. Right? It is decreasing your entropy after the split of the data set based on the attribute, right? So we fix that entropy is nothing but error. 1 minus entropy is nothing but your purity, right? Entropy is nothing but, you can also give another name is expected information, right? That's why you're writing this. You have sigma I equal to 1 to n, right? So this is something which you also calculate for two class scenario. You call it as binary cross entropy. This is nothing but optimization technique for categorical data. Y being categorical. Y being categorical. Right? So when I talk about information gain, now comes the how do you calculate based on entropy, how do you calculate the information gain? So information gain should be very, very high to pick up the right attribute, right? To pick up the right attribute, you have to calculate the information gain. So if your information gain, right, whatever you are getting here, as you already know, it's entropy before minus entropy after. But this entropy after can have n number of classes, n number of categories, I can say, right? Maybe you can have it like we are calculating entropy for individual class. Suppose you have medium class income. For income, you are calculating entropy after for income, and that particular column is having three different categories: medium income, high income, low income. So you calculate entropy for medium, for high income, plus low income. Whatever you are getting here, you subtract it from your entropy before, which is giving you the information gain, right? So more the information gain, that is selected as your attribute for the next level of calculation of your node selection. Okay, that is one thing. So when do you prefer, like which should be preferred among Gini impurity or entropy impurity? Okay, we also covered information gain here. Next, which should be preferred here? We'll write it as among Gini and entropy. Most of the times it does not make any difference, right? They go and they lead to the similar trees. So Gini impurity is a good default while implementing in your the algorithm we use is sklearn, right? It is slightly faster to compute. So when they work in different way, is that whenever you try to what we say, this entropy tends to produce a slightly little bit better, more balanced trees, right? So here Gini impurity tends to isolate your most frequent class in its own branch of a tree, right? So the Gini impurity or entropy, but Gini impurity does little bit quicker, right? So this is slightly more for balanced trees. It tries to produce a very good balanced tree, but Gini sometimes maybe it does not make it. Both are used for measuring impurity. Anything you can choose. That is our option. Whichever is giving you better results, you can restrict to that. Yeah. So what are the different types of nodes in a decision tree? We have understood that you are choosing a right attribute selection measure. But what are the different types? What are the different types of nodes in decision tree. Very, very easy. Because you have understood that in order to in order to attribute selection measure, in order to get the best attribute, we are calculating information gain, which is nothing but the entropy of a data segment or entropy of a particular data before the split and after the split. That is reduction in impurity. So what you have to remember with respect to information gain, higher difference represents higher information gain. Higher the difference means lower the entropy. Lower the entropy of all your data segments, whatever you are getting resultant from the split. Because higher the difference you have, higher the information gain you have, and better the feature can be used for the splitting. Right? So based on that higher information gain, you're starting with a root node, then you have your intermediate nodes, and then you have your leaf nodes. Right? 3. So intermediate nodes are also called as branch nodes or branch nodes. Leaf nodes are also called as terminal nodes. Root node as root node. Okay. Yeah. Feature scaling is important or not here. Do we require any feature scaling here? Feature scaling for decision trees. Explain. Do you require any feature scaling here? The best thing about decision tree is that it does not require much data preparation, right? It is very, very easy to interpret as well as it requires very, very less data preparation techniques to be applied here. And in fact, they don't require feature scaling or centering or standardization at all. Because of this reason, you call them as white box models, right? So decision trees provide simple classification rules based on your if and else statements, which can even be applied manually if need to be applied. It's very, very easy. There is not required. It is not at all a mandatory procedure for decision tree for feature scaling here, right? Very is one of the important point with respect to decision tree. Okay. How does this decision tree handle missing value attributes? How does this handle this particular problem? Handle missing value attributes or missing attribute values. Definitely, it will fill the missing value by most common value of that particular attribute, or else it will fill the missing value by assigning a probability to each of the possible value of that particular attribute based on your respective other samples. How we have to do the same way you have to handle the missing data here. Right? To each of the possible value, whatever you have, based on the other sample data, you take it and you try to solve it. Okay. Do you think this decision tree handles this continuous data easily? How do you deal with this? If at all you have, I just said yes, it works for both numeric and categorical data, mixed data. But how does this take care of this continuous data? Exactly, Paresh. Yeah. How does this decision tree handle continuous features now? Continuous data in the, if at all you have mixed, you have even few continuous, right? How does it do? How does decision tree handle continuous data? Decision tree, it handles continuous features by converting those continuous features into threshold based Boolean features, right? So what will you do there? First, you have to do discretization. You have to convert into different categories based on the Boolean features, threshold based Boolean features. Then to decide the threshold value, we use the concept of same information gain. You have to choose that particular threshold so that that will give you a maximization of your information gains, right? Maximization of information gain. Okay, that is one thing. So you perform discretization and you divide them into categories here. Now explain this feature selection. Using information gain, or both being the same, right? Entropy technique. Yeah, make into discrete. Yeah, explain feature selection here. So generally, we have few algorithms which do feature extraction, but this decision tree, the goal of this feature selection is you have to build a tree, select the right feature, which has to be split into the child nodes, and that when it's trying to split into the child nodes, what will happen? The combined entropy will add up to a lower entropy, right? And finally, the result, what you are getting is the information gain. Maximum information gain is given, that but particular feature is given more importance, right? Whichever, like entropy, before you calculate entropy gain, you calculate, you do a subtraction of it, you get the information gain for all the features you get. So you are giving importance to not all the features, only to that particular feature where your information gain is maximum. So that is what is the concept of feature selection, not feature extraction. Here it is a feature selection concept. And we are doing feature selection here. So whenever you are going for any attribute selection measure, whether it is information gain or gain ratio or Gini index, anything, information gain is something, it is biased towards your multi-valued attributes there, right? Gain ratio means it prefers unbalanced splits, in which one particular segment might be much smaller than the other segment. Mostly for unbalanced data splits, we use gain ratio as your attribute measure. When you go for Gini index, this is becoming this holds this does not work, we can say, good when your number of classes is very large. And also the disadvantage of decision tree is only that if at all you have so many classes in one particular column also, the tree will not hold good. The building of the tree is not apt, or it's not preferred. Decision tree algorithm is not preferred here. And that is one of the things we have to remember. Yeah. Are these trees even affected by outliers? Are decision trees? They are affected by outliers? Are decision trees affected by the outliers? So these are not sensitive to your noisy data or outliers, the first thing. Or you can call them as extreme values, noisy data, outliers, right? Because they never cause that much reduction in your RSS, that is residual sum of the squares, right? Doesn't matter if you have outliers also, it does not impact your residual sum of squares, RSS, because they are never involved in the split. So they are not at all affecting your tree building. So the answer is no. Decision trees are affected by outliers? No. They are not sensitive to outliers. Trees are not sensitive to outliers. Okay. Next. What are the hyperparameters for a decision tree? How do you tune a decision tree? Okay. Otherwise, let me put it in this way. What do you understand by pruning here? What do you understand by pruning here? See, for every classifier like knife base, you have Laplace, right? For knife base, you have, am I correct? Yeah, Laplace. For KNN algorithm, K. For decision tree also, you have to, because we have very big problem associated with the tree, because it is always prone to overfitting problem. Every time we have this problem with this. So what you have to do? You have to definitely reduce this, overcome this problem. So you definitely have to go and do some tuning to the parameters involved while building a decision tree. So what you do here? What is that we have to prefer? We know that decision tree is constructed from the scratch till the last depth, taking the attribute selection measure as information gain. If at all you are using ID3 algorithm, right? So this is a regularization technique. Pruning is a regularization technique. It is a process here. You are trying to adjust your decision tree, and the main aim of pruning is to minimize your classification error. What is the main motive of for any pruning, for this pruning concept in algorithm? You're minimizing the overfitting problem of the model, right? So basically, what are the types of pruning we have, right? What are these? You have may have post pruning, you may have pre pruning. When we remove your subnodes, right, of your decision node, this process is called as pruning, or you can also say that it is opposite process of your splitting. Widely broadly classified to pre and post. So when you talk about a technique, like the first one, pre-pruning, you will not allow the tree to grow, you pre-prune it. Right? You have a tree, it's growing. Right? You have one split is happening like this. You want to hold it here only. You don't want it to further split. Even before it will grow itself to the last level, you will not allow it to grow. Right? Even before the tree grows, early stopping prune. You can call it as pre-pruning is early stopping prune. We stop the tree growth even before it is completely built. You halt that particular subtree construction at some node after checking some measures. One particular attribute test condition is evaluated. That measure is nothing but your information gain, right? So before the tree grows, it is halted. So it is avoiding the overfitting problem. Means your tree is not entering into the complex subtrees. So definitely stop. That particular problem is resolved, right? The opposite of this is post prune is first you allow the tree to fully grow to the last depth it is built, right? You trim the nodes of this in the bottom up fashion, top we can say from here to here. Even after trimming, if the error increases, then we just replace those subtrees with your leaf nodes, right? So, but people feel that each and every algorithm, each and every technique, sorry, not algorithm, each and every technique has its pros and cons here. Post pruning is a type of pruning which is definitely used after construction of a decision tree, right? This tree is having very large depth. It is getting overfitted, and it is also known as post pruning is also known as backward pruning, right? This is used when you have infinitely grown decision trees, right? So pre-pruning is used before the construction here, and this is almost many times it will resolve your issue. So because it is not allowing the tree to grow totally, it is very quick, right? But post pruning has some interaction effect. It means that whenever a new attribute comes in, it should be fitted into the decision tree. You can use post pruning helps to do that, but pre pruning will not allow you to do that. Right? That is the biggest thing you can do. Post pruning definitely yes. It is not fast, but you have you know that where to cut your tree, where to stop your tree growing. This is pre pruning is just a guess, right? Yeah. So what are the parameters which are helping us to do this pruning? Prune the tree. The regulation technique is yes, but what are we using here to prune it? Yes, it will reduce the error. Yeah. What are the things which you have, like the weapons in your hand to stop this problem of overfitting? Because this is a major problem we have here. So first of all, we know that we are using sklearn. From that, you have a submodule called tree. From that, you are going classifier. Let us talk about only classifier as of now. If at all you have y being numeric, you can go for regressive because it is used for both the problems. Assume that you have calculated, you have just done some kind of pre-processing, whichever is required. Then you have passed your data to the algorithm. Right? You have just built a normal tree without any tuning here. You got to know that it is overfitting problem. Now, what are the weapons in your hand to reduce this overfitting problem. The hyperparameter tuning, look, whatever the parameters you have to tune. So remember there are a lot of difference between parameters and hyperparameters. Okay, remember that point. So first thing is that you have criteria. It's a very big list, right? You have so many things in your hand to do this. First thing is criteria, which you can try and give some change, because you can go for default or you can change it to entropy. Default is Gini and this is entropy, right? You have something called as splitter. This also you can choose. You want to go for a best split or you can go for a random split. The next weapon here is a maximum depth, right? How much depth you want to grow your tree. You want to grow your tree until all the leaves are pure. Now you know what is pure and what is impure, right? And until all the leaves contain, you want to give any condition, like you are deciding the depth of the tree. You have something called as minimum samples. Very important, friends. This particular thing you have to. It is good that if you memorize things for this. Minimum samples underscore split, right? So you are asking, you are just giving a condition saying that how many samples are required for the next split to occur. To split to a next node, how many samples should be left out? You are giving it here, right? The minimum number you have to give. If at all your number of samples are not satisfying this condition, it will stop growing, right? You have something called as maximum features. What is this maximum features? Maximum features is nothing but number of features you want to consider when you are going for the best split to occur, right? You can give many options there. You can go for automatic, right? You can go for square root of your features, log base 2 of your features. You can leave it to the algorithm itself to take the default value, right? This is one of these features. You have something called as maximum leaf nodes. Maximum features is number of features you want to use to build a tree. Maximum leaf nodes is grow a tree with the maximum leaf nodes in the best first fashion. So best nodes means you have to, when a tree is built, right? When it is splitting, the entropy also should decrease now. The optimization should happen here, right? So maximum number of leaf nodes you want. You want 4 leaf nodes, 5 leaf nodes. How much? You give as an integer here. If you are not giving and specifying anything, it will unlimited number of leaf nodes will go to the fully last. The depth will be very high. It will go totally. No pruning is happening there. You have minimum impurity decrease. And what is this? So decrease, you give this number, one threshold point will you give. Whenever a tree starts to the next slip, it goes to the next split, the impurity decrease. Impurity means the entropy decrease should be there. If the entropy decrease is not satisfying this, it should not split. It should stop here only. Further split should not happen here. And impurity decrease. You give some number now, 0.19, 0.16. Some number you give. So this is also will pre-prune your tree. So you have decrease is there, minimum impurity split is there. This is for your early stopping the tree, the growth. If its impurity is above the threshold, the node will split only if the impurity is above the threshold. Otherwise, it is a leaf node only. Right? And finally, you have CCP underscore alpha. The complexity parameter which is used for minimum cost complexity pruning. So the subtree with the largest cost complexity, that is smaller than CCP alpha, will be chosen. Okay, this is very, very important. This will help you. These all things will help you to reduce the overfitting problem here. Right? When you go for regression, what is that you use here? Instead of entropy, you use your mean square error. If it is a classification, you are using binary cross entropy, the entropic as your criteria here. If you go for regressor, you use mean square error as your criteria, MSE. MSE. Here, instead of entropy, you are using here MSE. This is for your regressor. Right? Okay. What are the advantages and disadvantages now for a tree, decision tree? Advantages and disadvantages of a decision tree. Very, very simple. Advantages will take first, right? So disadvantage is only one thing, right? So what is the advantage here? First thing is the tree, it's very, very easy algorithm, simple to understand, right? Interpret and visualize the data. Not much pre-processing is required, right? The output of a tree can be easily understood by the we people. Simple and easy to understand. Very, very clear visualization. How a root node is dividing into child nodes and then into leaf nodes, right? It can be used for both classification and regression problems. That is one advantage. It can handle both continuous and categorical variables. That is also an advantage. No feature scaling is required. That is also an advantage, right? Like your what do you say, that uncurve what is it, linear and non-linear parameters, right? It handles non-linear parameters also very, very efficiently, right? So the performance of tree cannot be affected by non-linear parameters. So these perform outrightly very, very good, perform better when compared to any other curve-based algorithms. Sometimes, many times, it will even handle your missing values. It will handle the outlier treatment. Exactly, right? They are very, very efficiently performing with these two problems also. And one more thing is that less training period. You go for any other ensemble technique, any other ensemble techniques like random forest or anything, right? It has less training period when compared to any other algorithm, any other ensemble technique algorithm, right? What are the disadvantages now? Overfitting, our favorite, our this thing. Because of overfitting, you have high variance, right? So the major problem is that it generally leads to overfitting. Why? It Overfitting is nothing but it performs very well on your training data, but it is not performing well on the new data. That is the overfitting problem. A tree becomes too complex to interpret when it keeps on growing. It loses its what we can say generalization capabilities. It will it starts making mistakes with your test data. That is the reason it is going into overfitting problem. So more chance that overfitting problem, high variance in the output leading to many errors, right? Shows high accuracy results for the training data, worst accuracy for the test data. So in order to achieve this zero bias, this whatever we have to go for take a call on bias and variance trade-off. And also, as I told you, if at all you have one column and that particular column is having multi-class, and that also many levels are there in this column, your decision tree could not perform well on that particular column, like because it is having so many levels. If the data size, if the tree, large data set is there also, one single tree may grow into very complex nodes, leading to overfitting. That time you will not use decision tree. It's a bad decision. And also it's very unstable. Why? Because if you add new data, so it can lead to the generation of the overall tree. All the nodes should be recalculated, reconstructed, right? So it's unstable. These are the disadvantages of decision trees. So because of this, people have chosen using this tree-based algorithms. We can go for ensemble techniques also, right? So the one of the first and the foremost and the most popular ensemble models are three are there, right? You can go for bagging, you can go for boosting, you can go for stacking. Three are the most popular ensemble techniques where we can use here. But out of all that, let us start with a random forest. It is an ensemble technique which is a supervised machine learning algorithm. And because it's the continuation of a decision tree, because it is constructed with respect to decision tree. Because forest holds lot of trees, right? So many decision trees are combined to get one algorithm, that is your random forest. So this is mostly it's very much important that we go for random first because it has its own advantages and disadvantages also. But let's get started with this. What do you mean by random forest algorithm? What is this random forest algorithm all about? It's very clever enough that this random forest, the popular thing about random forest is that it will never work with the whole data set, right? It takes the data randomly, it picks randomly, right? If at all you have n by n, it will never work with m rows and n columns. It will always work with subset of that, m into n, right? So here always now if you take any other ensemble technique, what it happens is that it takes all the columns, but it will take only subset of your rows. But here in random forest, both your rows are taken subset, even your columns are taken as subset, and it will build different decision trees. And the main objective here is it is reducing the problem to overcome the problem of overfitting. So how many trees you are building? One decision tree, 2, 3, 4, taking the average of all the decision trees built, that is your final result here. Different parts of the same training set. So it is trying to build so many decision trees at the time of training time, right? So single data set, you have an option to build number of decision trees, right? Tree 1, tree 2, tree 3. Aggregating the results here, right? You may go for averaging, or you may go for soft voting, or you may go for hard voting. Depending on that, you are getting your final result. the combination of all the trees here, right? So good thing is that yes, like decision tree regressor, you can also use random forest also for regressor and also for classification. That's why we can do average, we can go for soft and hard voting respectively. Why it is very popular? Why it is very popular and it is widely used among all the different classification algorithms? It, yes, you can use regressor also, but it performs very good for classification rather than regressor. First thing is yes, it is data preparation is very easy. That is where you are time saving is happening there. Why it's very popular? Very few assumptions are there here. First of all, it works marvelously well for large data sets. Few assumptions are there here. Very good for large data sets. It is reducing the overfitting problem here, right? Less time for data preparation. Because of that reason, it's very popular. And also, good thing is that it can be used for continuous data and also categorical target variables, right? Yeah, what is the main difference between random forest and the one more and the technique which we call as bagging, right? So let me ask you first, what do you mean by bagging? Then let us understand the difference between random forest and bagging. Tell me. What is bagging here? What happens in bagging? Ensemble models are nothing but you are building n number of trees onto the data, right? Multi-class classification can be done using different algorithms, right? You can go, yes, random forest also can go for multi-class classification problem. You can use SVM. Different algorithms are there which do wonderfully well on multi-class. Even a random forest does well. You can perform multi-class. What is this bagging? Yeah, from B, bootstrap, aggregating, right? So here it is involving bagging is also known as bootstrap aggregating, involving uh, new training sets here, right? So if at all you are picking a new training data set, because if at all you have 1,000, right, you are dividing it into maybe 5 samples. Sample 1, sample 2, sample 3, sample 4, sample 5. Each new training data sets a pick of sample of data points. You can choose now with replacement or without replacement. You want the sample with replacement or without replacement. By sampling with replacements means some points of now you have divided into 200, build a decision tree 1, 200, decision tree 2, decision tree 3, decision tree 4, decision tree 5. No replacement is happening here, right? But a sampling with replacement means first sample you are having 200. Some of the data points may be repeated again out of this 200. If you replace them, you pick a new 200. So repetition of whatever are there in sample 1 may be repeated in sample 2 also. So K models are fitted using K bootstrap samples form. Then for prediction, we are combining the results of all the trees by doing average of this. By doing average of this. So again, same thing. When you put average, you are taking voting concept or averaging concept. That is your output. This is my data. This is my bootstrap samples with replacement or without replacement. These are my models. These are my aggregation. This is my output. So if it is continuous, I go for this. If it is classification, I go for voting. If at all your data set is imbalanced data set, you have to go for cross validation technique, which is the most popular technique for imbalanced data sets, so that your training happens very well on all the parts of your training set. Right? Then you have to pick one particular part of your data for testing, so that your training happens good. Then you can evaluate your model also very well. There is many techniques are there, but the most popular technique is go for cross validation technique. Right? This is what is happening in bagging now. What happens in random forest? What is the procedure we are following for random forest algorithm? What happens here? First, you are picking. Bagging is something which is picking your samples, and the sample is picking all your columns. All these n columns are taken, maybe some subset here, some subset here, but it picks with all the columns. But random forest is picking even few features. Not all the features are selected in the decision tree 1, decision tree 2. It picks randomly columns also. Not only your rows, randomly picks your columns also. You choose number of trees you want in your algorithm. You will repeat the steps. You pick the records. You want how many trees you decide. Right? This is what happens in random forest. That's the only difference between your bagging and random forest here. Right? So all the three are very important. So when you go for bagging, when you go for boosting, right, these are the three ensemble techniques which we popularly consider, right? So bagging, what it is doing, it is waiting for the every decision tree to build, right? Data is there, sample is picked, performing decision tree 1, decision tree 2, decision tree 3. Take the output, take the output, take the output. But when it comes to boosting, what it will do, same data, same sample you are taking, with replacement, without replacement will continue. But decision tree 1 output is taken, it will pick the weak learners of the decision tree and it will involve those weak learners in the sample 2. Again build a decision tree 2, take the output, pick the wrongly predicted data points, observations, add them in sample 3. Here what is happening, it is not bothered about the weak learners. Here it is concentrating on the weak learners. So bagging, all the trees can be built parallelly. It is parallel processing, right? But when you take consider this boosting, it has to wait till the decision tree 1 output is coming out. It is popped out. Then sample 2 is built, then tree is built, again the output is taken. Check the wrongly predicted values, take them into sample 3, again build decision tree. So this is not parallel processing. It is nothing but you put under sequential processing because more concentration is happening on the weak learners. Mostly preferred is the samples are getting replaced. Same samples, whatever are fixed. Here also you can go for replacement, but here it is picking the weak learners first. Those are compulsorily pulled into sample 2. Right? That's the major difference between bagging and boosting algorithms. So with replacement, without replacement is a technique here. So same thing, the concept comes here averaging. Here also taking the average. Right? I think it's Abhilash. Hope it makes sense now. Right? So if at all you are having box of lottery tickets in which you have 100 unique numbers, you have unique numbers from 0 to 99. Definitely what will you do? You select some random sample of tickets from the box. If you put the tickets back in the box, it may be selected more than once. You have that option. So we are picking the samples randomly from the box with replacement. So again and again, your data is whatever you are doing, you are allowing it. Right? You are trying to train it again and again. If at all you are going for with replacement. No replacement means yes, you are happy. Whatever is coming out for the first time, you are going on. You are picking it. Right? So that is the major difference is that. So that's why bagging will take less time when compared to boosting. Because boosting is dependent on the first tree built. Right? Till this output is not popped out, it will not go for decision tree 2. Right? So random forest refers to mainly two process: random observations to grow each tree, random variable selected for splitting at each node. Right? It is random variable selection, some independent predictors. Say M are selected at random out of all the predicted variables, and the best split on this M is used to split the node. Right? So if at all you are selecting your features here, right, M remains constant during the algorithm run when the forest is totally growing. Right? You have to, if at all you are going for regression, random forest, if at all you are going for classification, the way you pick up the features is different. Right? So square root of the total number of predictors is by default for classification. Right? Number of features divided by 3 is for regression. Square root of features is for classification. This is how random forest takes importance of the features. Okay, so we'll stop here. We'll continue with the new set of questions next week. Thank you all for joining the session.